Alright, so this is just a quick note on how to determine whether or not something is in fact a function. So last chapter, actually rather chapter 1, we talked about how a function or a relation is a function if every input has one output. Well, now that we're going to start looking at graphs more, another way to determine whether or not a relation or an equation is a function is if it passes the vertical line test. So the idea here is you want to be able to picture drawing a vertical line anywhere on your graph. And if it crosses any place on the graph more than once, then it's not a function. So here's an example of something that would be a function. This green line here, where you can see that pretty decently, if I were to imagine drawing a vertical line anywhere along this graph, if I were to draw it here, or here, or here, wherever I were to draw it, it only ever intersects at one point. This line here intersects one point. This line here intersects at one point. So this, in fact, is a function. Every input has one output. Now, if we come over here and look at this example, this is not a function. The reason being is because I can draw a vertical line here, and it crosses not just once, but twice. I can also draw a vertical line here that crosses more than once, crosses twice, which means there are inputs that have more than one output. For example, this vertical line intersects my graph, this curved green line, at this point here, which is the point 1, 1, and it also intersects at this point here, which is the point 1, negative 1. So this vertical line crosses at more than one point because the input of 1 has more than one output. 1 has the output of 1, that creates 1 point, but it also has the output of negative 1. So therefore, that is not a function. And even if there were just one location on my graph where a vertical line crosses more than once, it would still be considered not a function, even if that only occurs in one location.